Today we would like to introduce the demo and performance of our rmNVMe-IP Core by Design Gateway. This video is the last and third part of our rmNVMe-IP Core video. Please check the first and second parts from the description below for more understanding. Let's see how to set up the demo and run it to check performance. To set up the hardware set for running the demo of our rmNVMe-IP for Gen 4, it consists of three components. Versal VCK190 Evaluation Kit, AB18 Adapter Board, NVMe Gen4 SSD. The AB18 adapter connects the NVMe Gen4 SSD to the VCK190 board via the PCIe connector. Next, we'll demonstrate how to write and read data with the SSD using the console. The rmNVMe-IP demo features transfer rate, allowing the user to set maximum data transfer rates for writing and reading on the NVMe SSD, expressed as a percentage of the maximum data rate. When set to 100%, the data transfer rate is at its maximum. For evaluating SSD performance in write-intensive, read-intensive, or mixed-use applications, the transfer rate is adjusted on the write and read interface. In write-intensive apps, the write transfer rate is set to 100%, while a lower rate, such as 20%, is set for reading to limit the read workload. For read-intensive apps, the read transfer rate is set to 100% for optimal performance and the write rate to a lower value such as 20%. Both write and read transfer rates are set to 100% for mixed-use apps to achieve maximum performance. First, let's see the write command with random access demo with two SSDs, Enterprise SSD and Commercial SSD. First, Intel P5800X, which is an Enterprise SSD, is demonstrated by using 4 KB random write to transfer 550 GB data. The write performance is very good, with constant speed at 5,900 MB per second. Next, the Commercial SSD, Samsung 980 Pro, is tested using the same condition, 4 KB random write for large data size. After 100 GB of data is written, the write speed drops from 4,200 MB per second to 700 MB per second. This is a common characteristic of commercial SSDs when the cache is full. It is important to consider when choosing an SSD that meets system requirements. Next, we'll demonstrate the read command with random access under different test conditions. The results of using the commercial Samsung 980 Pro SSD with command queue depths of 32 and 256 will be shown. The average read speed with 32 queues is 1,301 MB per second, and with 256 queues it's 3,542 MB per second. This shows that the read speed improves with a larger command queue depth. When using the Enterprise SSD, Intel P5800X, the read speed is about 6,397 MB per second for both 32 and 256 queue depth. Finally, let's see the demo when running the write and read commands simultaneously by using Intel P5800X SSD. Three conditions with different settings of write-read loading are demonstrated. First, the read speed is limited to 20% of the maximum line rate. Second, in contrast, the write speed is limited to 20% of the maximum line rate. Last, no limit is set to both write and read transfer. As shown in the comparison graph, the total performance, that is the sum of the write speed and the read speed of the three conditions, are not much different. Total performance is about 6,000 to 6,500 MB per second. The maximum line rate is equal to 8,800 MB per second, so 20% means 1,760 MB per second. For the first test that limits the read speed to 1,747 MB per second, the write speed is equal to the rest bandwidth of SSD, or 4,204 MB per second. For the second test, the write speed is limited to 1,732 MB per second while the read speed shows 4,833 MB per second. Last, the write and read speed are both equal to 3,036 MB per second. The Intel P5800X demonstrates a well-balanced performance for both write and read operations. When only write or read commands are executed, the read speed exceeds the write speed. However, when both write and read commands are set at the same rate, the performance of both write and read becomes equal. As a result, write-sensitive systems should reduce the number of read command requests to the rmNVMe-IP, while read-intensive systems should minimize the number of write command requests. It should be noted that some SSDs may exhibit different and unbalanced write-read performance when both commands are run simultaneously. Our demo is available for use to assess the characteristics of your own SSD. You can see the results of 3 SSDs are displayed in a graph when operating 4 KB random write and read tests using rmNVMe-IP. The graph shows that 3 SSDs exhibit a constant rate for the write command while adjusting the write command queue depth to values of 32, 64, 128, and 256. 2 SSDs display an increased read speed when the read command queue depth is set to a larger value. However, the Intel P5800X exhibits a constant rate with the highest performance during random access tests of 4 KB size for both write and read operations. So, rmNVMe-IP is designed to operate as fast as possible at PCIe Gen 4 speed, but the performance result mainly depended on SSD's characteristic. Our demo could help you to evaluate the best SSDs for your application. Hope this third-part video can help you understand our demo and performance result of our rmNVMe-IP core with NVMe Gen 4 SSD in real-world applications. For more technical detail, please visit our website designgateway.com or just click the link in the description below. Thank you for watching and see you in the next video.